Hello everybody and welcome back to another visual pattern challenge. Here is our pattern today. Here's step 1, step 2, step 3. They've given us step 4 today, and that's good because this is a tough pattern. Your challenge is to predict the number of squares in step 5. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see how far you can get. Okay, now this is an odd looking pattern. Let's just try to get some visual intuition about this first. I guess what I notice here is that there's this chunk, this rectangle of 6 squares, this 2 by 3 rectangle that kind of stays the same. I see that in every step. And then if I look at what's not that rectangle, I've got a 1 by 1 square, and then, well, it's sort of a 2 by 2 square, but then it overlaps. Oh, and then this is a 3 by 3 square with a chunk bitten out of it, like the whole lower right corner there. And then we get a 4 by 4, and there's a chunk bitten out, or it seems to overlap a little bit. So on the face of it, this is kind of confusing. I think what I'm going to do is count the squares and analyze the numbers first and see if that gives me any intuition. I would imagine we've got a quadratic going on here because we've got these squares, or at least parts of squares, growing over time. But let's look at the numbers and see if that gives us any clues about the direction we should take. So I'll make a chart with the step number and the number of squares. And let's see, in step 1, that's 6 plus 1 is 7. In step 2, we've got that 6, but now plus 3, so that's 9. And in step 3, 6 plus 6, 12. And in step 4, we've got that 6 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that should be 16. Okay. Now let's think about how this might look in step 5, and we can add that to the chart. So we'll have a little bit more to work with. What's staying constant here is this 6. So I think I'm going to have a chunk of 6 down here. And then this square or half square or whatever it is, it's 1 by 1, and then 2 by 2, and 3 by 3, and 4 by 4, but with part taken out of it. So I think this is going to be a 5 by 5 square. And the way that works here, so this is the 4 by 4 square. So I can think of it as a column of 4, and then of 3, and then of 2, and then of 1. So I think with the 5 by 5 chunk with part bitten out of it, you could think of it as a 5, and then a 4, and then a 3, and then a 2, and then a 1. So that's how I think this is going to look. Let's add up these numbers and see if it makes sense with these others. So let's see. 4 and 3 and 2 and 1, that's 10. So 5 and 6, 11. So 21. So in step 5, I'm getting 21. Now let's go ahead and do our differences. 9 minus 7 is 2. 12 minus 9 is 3. 16 minus 12 is 4. 21 minus 16 is 5. Aha. So it's not a constant here, so it's not linear. Let's take the difference of the differences, and we get 1 in the difference of the differences. Because we're getting a constant in the difference of the differences, we know it's quadratic, but this constant of 1 means that our coefficient of our x squared term is going to actually be 1/2. This difference of the differences, you divide that by 2 to get the coefficient of the x squared term. So that's a little funky, although it does fit with what we're seeing here, right? We're kind of seeing this part of a square, not a whole square. Although, it's not exactly half of the square, right? In this 3 by 3 square, we have 3, 4, 5, 6, and then 3 missing. So it's not exactly right. Analyzing these numbers, though, does clue me into the fact that I may have seen this pattern before. And let's just look at these pieces. So these are the other than the constant 6 every turn, I've got a pattern of 1 and then 3, and I'm just kind of flipping these on their sides, and then 1, 2, 3, 4, 5, 6. This I have seen once or twice before. These are the triangular numbers, and the next one would be 10. And yeah, that's exactly what we have up here. So this seems to be right. These are the triangular numbers. And I know from the past that the formula for the triangular numbers in equation would be x squared plus x, all of that divided by 2. So that should give me this chunk, the non-constant chunk, and then I just have that 6 to add to it. So this is a hard thing to see. If you don't have that equation for the triangular numbers in your head ahead of time, it's tough to get there from this. So you know, if you only get to you know how many in the next step and you're not able to get to an equation on this one, don't feel too badly. This is a really tough one. I suppose we should write down what's in the next step here. So that was 21. And then our equation, I think it's going to be this, but let's test it. So in step 1, we'd have 1 squared plus 1 divided by 2 plus 6. That'd be 2 over 2 is 1 plus 6 is 7. That makes sense. And then here we'd have 2 squared plus 2 divided by 2. 4 plus 2 is 6 divided by 2 is 3 plus 6 is 9. Yeah, that's how many there. How about step 3? We'll do one more here. 3 squared plus 3 divided by 2, 9, that'd be 12. So 6 plus 6 is 12. Yeah, that's how many we have in step 3. So this equation looks good. Y equals x squared plus x over 2. That's the triangular numbers, and then that 6 for a constant. So we just need to plug that all into step 43, or plug 43 in for x to figure out how many in step 43. So that would be 43 squared plus 43 over 2, and then plus 6. And 43 squared is 1849 plus 43 divided by 2. Let's see, that's 1892 divided by 2, and that's going to be 904, I'm running out of room, 946 plus 6. So 952 is what I'm getting. So check my math on that one, but I think we ended up at 952 squares in step 43. Well, how did that one go for you? I think this was really difficult. Keep your eye out for these triangular numbers. When you're seeing this pattern of 1, 3, 6, 10, when you get this a coefficient of, well, this difference of 1 in the difference of the differences, and the coefficient is 1/2, try out the formula for triangular numbers and see if that helps in these patterns. But let me know how this went for you. Thanks, everybody.